Welcome to lesson 11, and today we're going to be looking at arrays. Now I'm going to be honest with you, when I was a young programmer, arrays absolutely terrified me. I just found them so confusing. So I'm hoping today that we're going to learn a few things about arrays. We're going to start off by learning exactly what they are. Then the next problem that is very common with arrays is visualizing an array. It's much easier to program something when you can somehow have a picture in your mind of how the data actually works. So today I'm going to try and work quite hard to help you to visualize how the data is actually stored. We're going to look at different types of arrays, not just a single dimension array, but a multi-dimensional array. And if you're already confused, hopefully all will become clearer as we work our way through. Then of course we're going to do some coding. We're going to look at how to create an array, how to read from one, writing back to the array, and editing the array. And then finally, at the end of this, I'm also going to look at a few dangers and common errors in using arrays, because there are a couple of things that you can do with an array that are unusual, and you can get yourself into some sticky situations. So we're going to look at those. So let's get straight on with it and try and work out exactly what is going on. If you did lesson 6 on the Digital Town website, you'd have looked at different types of numeric variable, and you'd remember this little sketch, the numeric variable digital car park. It was a way of trying to visualize the data. And as you can see here, we've got a 1-bit, we've got 1 byte, which is 8 bits, we've got 2 bytes, 16 bits, which makes up an integer, and we've got 4 bytes, 32 bits, which would make up the data type that is called a long. And we looked at how a variable contains the various zeros and ones to make up that value. Now, when we start to look at an array, it has the same sort of variable types in that you can have a bit, a byte, an integer, or a long. You can use all exactly the same data types, but instead of it storing a single piece of information, it can store a multiple number of values of the same type. Now, one thing about an array, you can't have an integer and then a long in the same array. They are, if you're having an array that's integers, all the values have to be integers. So let's start to look at how the array works. So just like a normal variable integer that can hold a single value, if you remember, we looked at comparing it to a car park slot where we could put different vehicles of the same size into the space. So the value could change within that variable, but the variable was always the same size, the same data type. Here in our array, it's a similar system in that this is an integer, another integer, another one, another one, another one, another one. So I've got 6 elements in this array. Now the first thing to notice is that the first element starts at value 0 and the 6th element is 5. It's just something you've got to get used to when working with arrays, that they start at 0 and always work up to, if you like, however many elements are in your array, your highest numbered item will be the number of elements minus 1, because 0 was your first element. And so what we can look at now is, if you think of a car park analogy again, we've got 6 parking slots. They're all linked together. Imagine a row of parking spots side by side, and different vehicles, different integers can be put in and out of the different parking slot. So that is how, if you like, a single dimensional array would be created. Now the next type of array we're going to look at is a 2-dimensional array. So as we've seen before, we've got our slots. Each one can take an integer. I've taken the numeric values out and put the array addresses in. So if you can imagine, we've got slots 0 to 5, and you'll notice 0, 1, 2, 3, 4, 5. But before them, in the square brackets, you've got what I'm going to call the row. So imagine now we're in a big car park, and there are rows of parking spots, one line after another, and it's a bit like we're now going to go and find our parking spot. In my local car park, you go to sort of A3. A would be the area, 3 would be the slot number. Unfortunately, we don't use letters, so instead we have row 0, row 1, row 2, row 3, and then within that row, each row has its 6 parking slots. So again, we've got slots 0 to 5, and we've got rows 0 to 3. The first number is the row, the second number is the slot. I hope this is clear to you, and you will see as we progress that we can have a three-dimensional array as well. So now as we look at our array, as we're looking at the three-dimensional version, we can start to see that just like before, we've got our slots and we've got our rows, but you'll notice now we've got a third value, and in this case I'm going to call it the floor value. So if we now imagine ourselves in a multi-story car park, on each floor we have a set of parking slots in a row, so we've got our slots that are in rows, and then of course we have exactly the same on each floor. So we've got the end value is our slot number, the middle value now becomes our row number, and the first value becomes the floor that these slots and rows are on. So on this one we've got a 3-floor parking multi-story car park. So we've got floors, because we start at 0, 0, 1 and 2. And if you start to look at this, you start to realize just how many bits of data we are now storing. Now, it's a little bit complicated to try and visualize these things, and this is why I'm trying to use the car park analogy. And what we're going to do now is learn to code these up, and we're going to continue using the car park analogy within our code. So I've got the IDE started, and I've already got some code in here for you to see. The first bit that we're going to look at is how we define an array. Now, if you remember how you define a normal integer variable, we just put the value int, and as we can see there's one here. I've got int car park slot counter equals 0. There's another one here where I don't give it a value, I just give it int main counter. As we're going to use an integer variable type for our array, we could have used a long or an unsigned long, anything I wanted, but we're just going to use an integer for these examples. The difference here is we define the name in the same way, so our variable name is car park, but because it is an array with 6 elements, you have the angle brackets here with a 6 inside. And then what I've done, if we look at car park slot counter, I've given it a value of 0. Because I've got 6 elements here, I'm giving it the values of 1, 2, 3, 4, 5 and 6. So I'm going to put a value in each slot, and that's how you would preload the values into this single dimensional array. Now I've started the serial so that we can see the output. I've defined a local variable q, and I'm going to show you why. And the first thing I'm going to do is just serial print out all the values that we've put in to start with. So what we're going to do is we're going to work from q equals 0 to q is smaller than 6. Now this is a very useful way of working through an array, because you start with position 0. If you know you've got 6 elements, if you're going to work up to a value that's smaller than 6, you're always going to get the complete array. So this is a very useful for statement for working through an array, and you'll see in the final sketch that we do the dangers that you can have if you exceed the limits of your array. So it's very, very important if you've got a 6-element array that we work through from value 0 to 5. If we went to value 6, we would have gone over the edge of the array. So what we're going to do is serial print out a single value. So we've got car park Q, so it'll start car park element 0, car park element 1, car park element 2, and if we look over here in the serial monitor, because I've always printed it out, we can see that car park element 0 is 1, and that is the value that we put in over here, and as we can see we can work through to position 6, which is 5. I know that sounds a little bit weird, but because position 6 is value 5, because we start with 0, it's just something you have to get used to. That's the oddity of arrays, and if you think you've got a bug, usually it's because you're looking, as we're doing in this one, we're going to look at the print out the third value in the array. So I put a 2 in here because the first value is 0, second value is 1, third value is 2. It's a little bit weird, but if we put the third value in, we're going to get a 3, and that third value is in, we have to put a 2 in to get it out. Again, a little bit strange, but you'll get used to it. Now what I've done here, I've got the variable car park slot counter, and you'll see why we're going to use this as we go through the different sketches. So instead of using a value of Q, I've used the car park slot counter, so it's exactly the same code as here, just this time we're using car park slot counter instead of Q. And so what it does is, once again, it prints out the various values, and then I'm printing out the third, that should actually be the fourth value, isn't it? And that value is defined by the value 3. You can see how confusing this can get at times. So the fourth slot has a value of 3, has a position value of 3, so that's going to be a 3 going in there, and that will give us 4. You may have to work through this slowly just to figure it out, but once you can get the hang of this little bit, you'll start to see how you can pull out different values. And what I would advise you to do on your own is to start thinking to yourself, okay, how would I get the fifth value out? How would I get the second value out? How would I get the first value out? And just start to work through these things on your own until you get used to it. Now, once you've got the hang of that section, we're then going to go down to the main loop, and we're going to continue using the same for loop with our car park slot counter, and this time I'm going to change the values in the array. So what's going to happen this time is we're going to work through as we did before, going from value 0 to value 5, because it's going to be smaller than 6. And then what we're going to do is we're going to use the value of main counter, and then we're going to increment that by 1, and then we're going to print out the new value. So at any time you can change the value of any element of an array, and then what we're going to do once we've done that, just to show you how to do a little bit of manipulation of values, we're going to work through all the values again, and this time we're going to add 100 to the values as we go through. So you'll see, first of all, you'll see the value here, main counter's value that we've set it to. When it runs through the second time, you will see the value that has been altered and 100 has been added. So we'll quickly compile that up. Hopefully it's not going to take too long. Right, so we've got our initial values as before, and now, as you can see, the new values are starting to come through, and I'll stop the auto scroll once we've got a few through. That'll do. So that's the end of that line there. So this is why I put these texts in. So we're now going to start to change the values in the array. So change the values in the array. We've worked through, and we're putting in the value of main counter that when it started had a value of 0, and it keeps increasing. So we've got 0, 1, 2, 3, 4, 5. So we've changed the value there of the different elements of the array. If you remember before, they used to be 1 to 6, now they're 0 to 5. And then we've added 100 to the values in the array in the second loop. So we can see we've taken the array value and then we've made it equal to that array value plus 100, and then we see these values coming out. Now, because main counter doesn't get reset, when the loop goes round again, it puts a new value into the different positions. So now we've got values 6 to 11, and once again we add 100 to them. So that is how we, if you like, we put our initial values in. If you want to put them in, you don't have to put them in. You could just make it look like that, and if it looks like that, then all the values in there will be 0. Then, and in fact in the next examples I won't be putting initial values in. So we've learnt now how to work through and print out the different elements of the array. We've learnt out how to pick out an individual element of the array. We've then seen how to change the value in an array, and we've then seen how to change the value mathematically in an array, how we can add or subtract from an item in the array. So that's how a single dimensional array works. Now what we're going to do is move on to something a little bit more complex. We're going to start to look at the two-dimensional array. So here we are with our two-dimensional array, and if you think back to the car park example, we still have our 6 parking slots, but this time we have 4 rows of 6 parking slots. So 4 is the number of the rows, 6 is the number of slots in each row, and to keep the car park analogy, this time we're going to make the array. Now if you remember last time it was car park and then in angle brackets we just had a 6, but because we're now in a two-dimensional array, we put a 4 in first for the rows and then 6 for the number of slots. And we've kept our integer for car park slot counter, but I've introduced a new variable, car park row counter. Now you'll notice this time with the array I haven't put in any initial values, so the initial values will all be 0. I've got nothing in the setup apart from starting the serial monitor, so let's go straight down to the main loop. So this time we have a for statement, which is now we're going to work through the rows. So the rows from 0 to smaller than 4, because if you remember we've got 4 rows, and then inside that I've got another for loop, which is the loop that we had before, which is counting from 0 to 5, which is smaller than 6, which is going through the slots. So what we're going to do is we're going to work our way through each row, and then we're going to work through, as we get to each row, we're going to work through each slot in each row. I hope you're following this one. Okay, so what we're going to do is we're going to start off by putting a value in, and so what we do, we start off with car park row counter, which initially will be 0, and we're going to put the car park slot counter, which will be 0. So the first value that it's going to put in, main counter, will go into position 0, 0. Then the inner loop will start to increment, so we'll go 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, and then it'll go 1, 0, 1, 1, 1, 2, 1, 3, and so it will continue to work its way through. Now, to show you what's going on, what we'll do is we'll keep incrementing the main counter, and then as we've created each value, we're going to print it out, and that's what's going on up here. So for our first row in the array, we went, the main counter started at 0, so it puts in the values of 0 to 5. That's the first row, all 6 slots. Then it continues, the second row, all 6 slots, it adds a value. The third row, all 6 slots. The fourth row, all 6 slots. Now, what I've done is I've made it put a comma, which is here, after each value, and then at the end of the line I've just basically made it print a carriage return, just so it jumps down to the next line to make it clearer how the array is formatted. Now, after that, in the code, I've then asked it to print out the second item, so the second row, 4th item. Okay, so that would be the 4th slot in row 2. And so what we now see is row 2, because we start at 0, we put a 1 in, and because we want the 4th item, we have to put a 3 in. Again, I've put some explanation in the code, there's some comments in there just to help you out. And then just to show how we manipulate things, I've put in here the value of that same one here, and here we're adding 100 to it. Now you'll notice this time I've used a different format of adding 100. It's in the reference. Again, don't forget the reference is your friend. Go to the reference. It says it's jumped up on a different screen. Let's bring it through. So if you want to find out these different mathematical symbols, they are down here under compound operators. So this is the one we're using today in this little example, compound addition. And don't forget there's more information on arrays by going into the data types and the data type array. Don't forget the reference is there to help you. Never be ashamed to use the manual. So going back to our code, we're just going to add 100 to the value, which is what happens here. So we know the value here is 9. We've then, just as an experiment, added 100 to it, and I've printed out the same value again. So we're seeing here, print out the value, second row, 4th item. We've added 100 to it, and we've printed it out again. Now, what I then did afterwards was I went through the entire array again, and this time I've added 1,000. Now I've done it in 2 different ways. What I did was I've done it the one method where you take the array element and then we equals that same array element plus 1,000, and then I've done the same, that line that I've written here can be written in this way, just to give another example of how to use this particular operator. Now of course, because I've added 1,000 here and 1,000 here, it doesn't add a value of 1,000, it finishes up adding a value of 2,000 because it's added the value twice. And then all I've done is worked through the array again to print out those values to show you what's going on. So we've added the 2,000, we see all the values coming through. Then what happens when it's done that, it jumps back to the beginning of the code again, and then it puts a new set of values in the array as we see here. So we've got again row 0, value slots 0 to 5, row 1, row 2, row 3, and then we're doing exactly the same over and over again. So that is basically how a two-dimensional array works. So if you think about it, you've got our rows and our slots, and we are working through using these two numbers, the row number and now the slot number. Now we're just going to make it a little bit more complicated to finish our tutorial on the basics of arrays. I'm going to do a three-dimensional array. So let's get our heads spinning a bit on a three-dimensional array. Think back to the diagram I did earlier. We're now going to have three values of floors, 0, 1 and 2. As before, we've got 4 rows, and in each row we've got 6 slots. So we're going to have, so first of all we've got how we define our array. So if we look, we do our floors, then our rows, then our slots. This time we've got our slot counter as before, we've got our row counter, and I've added a new variable, the floor counter. And if we look at our code, it's very, very similar to before. We've got an extra for loop that's been added, and this time of course we have the 3 elements to the array because it's a three-dimensional array, and we've got the floor element, the row element and the slot element. And again we're going to use main counter and just increase the values, and then we're going to print them out. And what I've done this time to make it a little bit easier is we're going to print out the element again using floor, row and slot, comma after each value, a carriage return at the end, and then what I've added is end of floor, so you know where on earth we are. So if we look at the output of that, just like before, we see our 6 elements in 4 rows, but then we get to the end of floor 0. We then continue 6 elements, 4 rows, then we get to the end of floor 1. 6 elements, 4 rows, that's the end of floor 2. So just like before, you're now working through all of these different items, and this is where you start to see just how many values and how much data you can process quickly with an array. Now, just as before, I've done an example of here of how to find an element in position 2. So we're on floor 1, which is a 0, second row, which is a 1, fourth item, which is a 3. So again, do yourself some little experiments and learn how to pick out the item. And as we can see, the value is 9 that we're printing out because that's where it has picked it out from, floor 0, or so the first floor, second row, fourth item. I've then, just as I've done before, I've added a value of 1000, again just to show how it can be done. There's nothing really new in here except in each time you're seeing how to use a three-dimensional array. 1 and 2 dimensional arrays are quite common. 3-dimensional arrays get to be less and less. Basically, the more dimensions, the more complicated it is to get your head round, and we could go to a 4th dimension, where in which case we'd almost be thinking of, okay, we've got the slots in the car park, we've got the rows that the slots are in, we've got the floors that the rows and slots are on, and then if we went to a 4th dimension, we'd now have multiple car parks with all of those items in. Can get a little bit weird to get your head round, but that's sort of the way that it works. Now I'm not going to spend any time on this because I now want to jump to a couple of very basic errors that you can find when you're working with arrays. So some dangers and problems with arrays. So I've used exactly the same script as the last time with the three-dimensional array, but this time we're going to look at how errors or problems can come about. So before I've used sort of 3 or 4 floors, I think it was 3 floors, 4 rows and 6 slots. Now you'll notice this time I've got 2 floors, 16 rows, 500 slots, and that means I've got 16,000 values that I'm storing, and incredibly an Arduino Uno will store it, and as you can see on the right hand side it will even print out the values as before without any problems whatsoever. However, now I'm going to show you where the problems come in. So I'm going to comment that out and let's compile this and see what happens. So I've compiled my code, and as you can see I get an error that says car park is too large. And what I did, I spent a bit of time working this out before I actually did the tutorial. If I change this value here from 16 to 17, I finish up with 17,000 integers being stored, and it runs out of memory. There just isn't enough space in my poor little Uno to store all of this data. So you then get an error that your array is too large. Now, okay, this is a three-dimensional array. You probably won't work with one of those, but you could even have a one-dimensional array that had 17,000 elements in it, and that would be too large. Now you think, where on earth would you use 17,000 elements? Well, if you were processing values from a sensor, you're reading values in off an SD card or something like that, these are just things that you have to bear in mind, that if you read enough data into an array, you will run out of memory. There just won't be enough space for the Arduino to store everything. Now, there is a way round this, and I'm going to show you another error in a moment, but both of these errors can be got round by using a processor with more memory. So if you use something like an Arduino Duo or an Arduino Mega, they have more memory space, so they can store these bigger programs. And this is why sometimes you'll see people using a Mega or a Duo. They don't necessarily need the pins, but what they need is the extra memory to store all this information. Now I'm going to comment this back and put it back to how it was, and I'm going to show you my next error. So let's press the compile button. So I've set the program back to how it was, and you can see that it's all happily working. But what I've done is, in my loop I've added a second set of code. So what it's able to do is it's processing this first set of code, and then what I've added is a set of code that has been commented out. I'm going to uncopy it so that you can see a different type of memory error. I'll quickly compile this one up and let's see the error. I need some kind of music to play while this is compiling. Right, there we go. Not enough memory. Now what you'll see here is that I'm trying to use 1582% of my dynamic memory. So if you like, I had enough memory to create the array. There's no problem creating this section because we're using the 16 instead of the 17. If I went to 17, we wouldn't even get this far. But now when it starts to try and process all of this data, if you can imagine, it's trying to manipulate all of these things in RAM, and it runs out of memory. It just cannot do it. So when you're working with arrays, one of the things you have to be aware of is that you can run out of memory not only by the amount of data that you are storing, but also by the way that the data that you've got is being manipulated. So if you're doing lots and lots of things with a huge amount of data, you can very easily run out of memory. And again, this code runs fine on an Arduino Duo, because I checked it earlier, because that has more memory. So it's something to be aware of, that if you're processing huge amounts of data, which thankfully most of the time you won't be, but if you start to come across this kind of error, it's due to the fact that you have literally run out of memory. Now we're going to skip on to one last sketch, which is going to look at a very, very specific error that can be caused when using arrays. Now I've gone back to a very simple one-dimensional array. I'm just going to use basically the sketch that we started with, 6 elements in our array, and I've put the values in 1 to 6. And this time we're going to look at what happens when you overrun the end of an array. Now one of the things with C++ is that it does not look after this bit of code. Now if you remember, our original code was from car park slots equals 0 to car park slots is smaller than 6, because we have 6 elements in the array. What I've done in this example is I've increased this to 10. Now what will happen if I just run this, you'll see that the first 6 items, element 0, 1, 2, 3, 4, 5, so our first 6 elements, we get the results that we would expect. Then all of a sudden I get a value of 2573, 24832, 29298, 31073. What has actually happened is that I have started to read the memory at the next locations. So I am actually reading from memory that is not inside the array. And the danger here is that that could contain data for anything. If you can imagine, the Arduino is now reading from a section of memory that has not been set apart for this array. This could be connected with all sorts of different things within the program. Now, reading these values gives some oddities, to put it mildly, and it's why you need to think about this kind of thing. The biggest error is where you've got 6 elements in an array and you try and read element 6 and you type in a 6 instead of a 5, forgetting that you started with 0. That's the most common time that this happens, and of course it will suddenly cause some really funny bits in your code. Now in the bottom of this example, God dear, my spelling is terrible. I'm going to show you something else that you should never do. I'm going to uncomment this and compile it up. So I've compiled up the code, and as you can see there are no errors whatsoever. So what I've done is, just like before, I've overrun reading the end of the array. You'll notice I haven't got the serial monitor open at the moment, and you'll see why in a second. Now what I've done is I'm going to change the values in the array exceeding the array limits. So it's one thing to read those values, that doesn't actually cause a problem apart from I get a weird value, but we're now going to look at what happens if I start changing the values of things outside of the array, because what I'm actually doing is writing to bits of memory that are being used for other things. I'm corrupting my own memory. Now, when you're doing this, you're not going to cause any damage to your Arduino, but you are going to get some pretty weird outputs. And then what I've done, just to add even more damage, I'm going to add some different values and just alter things a bit. That should be 100 there. So I'm going to add these extra values and you'll see what happens. So I'm going to start the serial monitor and let's see what goes on. Bonk, it's going absolutely bonkers. I'm going to stop it. Now it shouldn't be going bonkers because the same delays are in, but the reason it's going bonkers is because I am writing to values. I may be changing the delay values because I'm writing to bits of memory that I shouldn't touch. So if we look now, if you notice here, when I do my initial overrun, if you remember before I had really big numbers in here. Now 2 of these values are 0, and that's because these values that are outside of the array are being used for other things, so their values are being changed. I have no control over these whatsoever. I can read them without causing damage, but then what happens is I actually start changing these values for myself and then altering them. And all of a sudden, as you start to look at my code, you'll start to see that I'm starting getting silly symbols appearing here. As you can see, if I turn the auto scroll on, it's scrolling like a lunatic. It's all going wrong. And this is because I am changing memory values outside of the array, and I'm basically corrupting the Arduino's memory. So if you suddenly start to get weird things happening when you're using arrays, take a look at the values you're using and make sure that you are not writing or reading from values that are greater than the number of elements that you have in your array. It's a simple error to make, and the problem is you will not get an error in the compilation of your code. But as you can see, you're going to get some really weird things happening as you start to run the program. Well, I hope this lesson's been useful to you and that you have a better understanding of arrays. You now understand what they are. They are a method of storing multiple values of the same data type in an organized way. I'm hoping, using the car park analogy, that you've sort of tried to visualize how the data is stored, and that gives you a better understanding of how multi-dimensional arrays work, which can be very, very confusing at first. And we've now learnt how to create the array, to read from it, write to it, and edit the array. And finally, of course, we've seen the dangers that can happen and how you can run out of different types of memory, and also the errors that can occur when you either read or write data outside the boundaries of the array. I would advise you, when you start this, to basically use the first array example. Learn to do a single dimensional array. They are the ones that you'll use most of all. Work your way through that, get your head around that, and then jump into the two-dimensional array. Try that, add some extra elements, just work through it, get it straight in your own head. Don't worry so much about the three-dimensional array or even four-dimensional arrays. You can do some experiments if you want. They can get very, very complicated, and you don't tend to use them as often as a one or two-dimensional array. And don't forget those dangers and errors that can occur. Any problems, leave some comments on the Digital Town website and I'll get back to you. And don't forget, all the code is available on the Digital Town website anytime you want. Thanks for watching, and if you enjoyed it, click the like or subscribe button. Bye for now.